more expensive than building a software, and typically it's 10x. Organizations focus on hiring good software developers, but they don't care as much about the operations and the running part, and they see it as somebody else's problem, which itself becomes a problem. And if you think about it, incentives are not aligned. So there's organizations have that typical proverbial wall between the devs and the operators. And the devs build stuff and they throw it off the wall. And now operators have to juggle like green things, yellow things, red things sometimes. And it's not, it doesn't scale well. So the incentives for the devs are always, let's build something new, let's add more features, let's give this to the user. Where the operators, they would love to slow down, maybe actually stop releasing anything. They would want to reduce the risks. And it's not harmony at all. Well, DevOps, if I ask anybody in the room, everybody has their own definition. This is my definition. So it's a set of practices, guidelines, and culture designed to break down silos in IT development, operations, architecture, networking, and security. And we think of SRE as an implementation of DevOps. A set of practices that we found to work, some beliefs, and also a job role that I personally been doing. To step back a bit, if we consider the whole product lifecycle, we have the concept, we vet it from the business, they say if it's yes or no. We go through the development phase. After we've developed, we pass it over the wall to the operations team, and they run the product and basically help making money for the organization. Now there are a couple of friction points. There's the wall between the business and development, and Agile is currently in the development and operation the solution for solving this, and which we typically think as being DevOps. Now, what's SRE? It appeared in Google in 2003, so we think about it as a framework to operate and scale systems reliably. And our VP, Ben Traynor, quipped that it's what happens when you ask a software engineer to design an operation functions. It typically emphasizes more on the engineering solutions, and running the systems in production is part of the philosophy. It's also versatile, so if you have mission-critical systems that like support 10 or 20 developers, it could also support teams big as 200, 300 developers. And this talk is not about selling you SRE. This talk is about once you decide that SRE is something that you want for your organization, it's what are the first steps I should do to bring it for me. And these are the principles. I will go step by step into each one of them. The first one is that SREs need service level objectives, or SLOs, as I'll shorthand it, with consequences. So it's not enough for us to just make them and just look at them. We need consequences. SREs must have time to make tomorrow better than today. SREs team should have the ability to regulate their own workload. And failure is an opportunity to improve. So site reliability engineers and the organization should remove failure from the vocabulary, because when things go wrong, blame will incentivize covering up and not actually stepping up and fixing the problem. And if we address the system and the problems, it will increase the reliability of the system. And in the end, if you think about it, you cannot run an effective organization based on fear. People will hide things from you, and that will just kick the can down the road. And that's where I think SRE fits in. That's the problem that it tries to solve. Because we give a common language to all three of the shards involved in the process, and we give shared goals, you take any negativity from the decision making. Now, if you ask the developers, hey, let's stop releasing any more software, it's shared and agreed upon all the key stakeholders in this process. Now, getting started is daunting, and I've well and good talked about principles in an abstract way. Let's get down through the steps that we need. And the first foundational one are SLOs, service level objectives. We use them to understand how reliable are our systems. What's an SLO? It's the goal for reliability. It's what meets the needs of our users. If we meet them, our customers love us, they praise us, and they're happy. If we don't meet them, they are sad, they're angry, they're frustrated, and probably they'll just leave our platform or our product. And the typical example is uptime. Is your site up? If we're talking about web application, we as engineers go and translate this in have 99% of my requests in a particular month or a week or a quarter have been successful to hundreds. That's how we tend to codify it, but for our business stakeholders, it just means was our site up. We can also go down more into details, like was our site fast? Were 90% of our requests in returning under 300 milliseconds? Or once you start understanding what your users care about, these can become more and more complex. So let's say if your users care about the freshness of some data pipeline, you might have an SLO that cares about how many log entries you processed in a particular amount of time. And again, you need to understand what your users want, but these are always good starting points. And to disambiguate a bit, I think you've heard about SLAs. SLAs are legal agreements, and they're between organizations. And SLAs involve dollars and lawyers, usually. SLOs don't involve any of these. If you meet SLAs, your users probably are not happy. It's the SLOs where you set the thresholds for your users. And my definition of a SLO is that if it's good, when it becomes bad, the customers will start getting unhappy. However, the SLA part is it's when they actually want to leave the platform, which should be very, very, very long in time. And another rule of thumb is that SLOs should be inside the company, so between the engineers and the ops teams, whereas SLAs are outside of the company, between your cloud provider and yourself, or yourself and a third-party payment provider. So once you have SLOs, what do you do next? It's not enough to have these metrics and track them. It's about having consequences when you break them. So I'm going to introduce the error budget policy. And this budget is not a financial budget. It's about improving reliability. It's about what happens when now you think your product was not reliable enough. And to have this policy, you should go and talk with your leaders and your stakeholders and ask them, how reliable do you want the product to be? Unfortunately, that doesn't work that well, because what I've seen is if you go and ask people how reliable would your thing want to be, they would always say more. As much as you can. Can you be 100% reliable? Can you not have anything happen? Can you be perfect? I mean, you said reliable, it should be 100%. It's the obvious answer. Unfortunately, we know as engineers that that's not true. And we know that perfect systems don't exist. Or if they exist, they're in a vacuum, sealed somewhere outside of reality. And you cannot touch them or change them. They're frozen there. And in the end, it becomes impossible to have 100% as reliability. To add further to that, there's Murphy's Law that tells us that anything can go wrong will go wrong. And to add even further, anything that could go wrong will go wrong at the worst possible moment, when you don't want, before that launch, before that expansion, when you have the press coverage. That's when that particular bug that you introduced 9 months ago and you thought, it will scale enough, that's when it will happen. And with all of these, I don't think 100% exists. And our VP of 24/7 engineering thinks the same. It's the wrong target for basically everything. And to even step back, will your users notice if you're not 100% reliable? Would they even care that you had that those minutes that you lost? I don't think so, and none of the products in Google are 100% reliable. So SRE becomes a job of balance. It becomes thinking about all these competing concerns and what other people want. And it's focused on establishing what's the acceptable level of failure that we should have in our systems. And is this good? Is this right? How do we measure this? How do we know that we measure it correctly? And once you have that, you then can move faster, if you can, and respond to failure appropriately when it happens. So now that we know that 100% is not the right target, we have our error budget. And this error budget is the difference between a 100% and the target that we've set. And while we remain within the budget, we're more reliable in our goals. And when we run out of our budget, we invoke the agreed consequences. To take a simple example, given the uptime of 99.9%, after 20 minutes of outage, you still have 23 minutes of budget remaining for the month. You have this incident, and that budget is meant to be spent because you've agreed that that exists. As a caveat, that doesn't mean that you don't respond to incidents. That doesn't mean you start an incident with, oh, I have 43 minutes to fix this. So no, it's not about wasting the budget. It's about reacting with the level of urgency, and it's about having the checks and balance in place to maintain it. And what you do when you spend the budget, well, this means you didn't meet your objectives and means something has to change. And it's not financial, it's not you go and ask somebody for money, it's about something visible for your reliability. And some examples are going to your developers and telling them no new features are allowed until we're within our budget. Or telling them that the next sprint planning will get only action items that fix reliability. Or even worse things like we will meet daily and we will talk with you about the reliability of the system. And these policies are specific for your own organization. Not all of these can help you. And also, you need support from your highest level in your organization. So your stakeholders do need to understand that these are needed when you are not reliable enough. To summarize, SRE needs service level objectives and they need consequences for that. Delving further into this, even without hiring a single SRE, you can have your own error budget policy. And this is a lever that you can pull when your users are experiencing sadness. And you can start with this today. You can measure, you can account for it, and you can act on it. And it's the first principle for getting started with SRE. Now, the second principle is making tomorrow better than today. And this is where we start talking about what your first SRE engineer would do, or what your first team would do. And how would you enable them to succeed in your organization? And it's not just, they're not just there to, I mean, you can have an SRE team if you take a team and you stick SRE on their door, but that's not going to mean they will succeed. While SLOs and error budgets are the first step, next is defining that somebody has an SRE role and they have the real responsibility to define these budgets and this policy. And they should be engaged with the operating of the system that they define as policy, and they should be empowered to do so and take actions when these things go wrong. Now, after, let's say they define and refine those objectives, they're also the best one place to respond to the needs. They should understand your users directly, and it's important for your stakeholders to understand that reliability is a key feature and it's probably the most important feature. Because if your product is down, it doesn't matter what other features you added to your product. None of your users will be able to use them. You will observe that when talking about tomorrow being better than today, there is this concept called Toil, and here I think about any manual, repetitive, automatable, reactive task that does not add any value for tomorrow or the future, but it grows with the amount of features that you add to your product. So any command that you have to run to deploy this extra new feature, any playbook that's wrongly written, any part of this work that's not, any engineer would dislike it, basically, if they would do it repetitively. This should exist, and this should be bounded. Those are the key things. In Google, we put the cap at 50% of your time, this should be, but 50% it's already too high if you ask other SREs. If your SREs go over half of their time dealing with this kind of operational work, then they won't have any time to fix your product underneath and make it better for tomorrow. Your SREs are just becoming an ops team. And because SREs are engineers, they need engineering project to work on. And typically these are these examples. So consulting on the system architecture, authoring or improving the monitoring system and alerts, automating the repetitive tasks, and coordinating the post-mortem items that you've discovered during your previous incidents. By giving SRE teams the time for this project work, it will first make them happier in the short term because they won't do the automatable things that drive me and other people nuts. And in the longer term, it will make your system be more robust. There's this constant fear of overload because Toil is a bit of, oh, it seems small today, it seems small tomorrow, but in the long term, it all adds up and adds up if you don't fix the underneath problem. And you could, in no time, just be in constant overload, just fighting. To recap, as an SRE, as SREs, people need time to make tomorrow better than today. And you can do this by capping the effort on ops work and providing them space to do other type of work. SRE should not suffer under operational load. And brighter means things different in different organizations. And your SREs will probably know what's the most important thing to do for their system. Now, let's talk a bit about the workload and how do we regulate them. And I think SREs should have their own initiative and should come up with their own project work. Teams should be responsible for running the mission-critical software in production and keeping it reliable. So this, while this might not mean, might not be what you would have typically in your organization when you start, because typically organizations start by adding 1 or 2 SREs to existing teams. I do feel like sharing the lessons from organizations that already have bigger SRE teams that engage with other teams might help you treat those people better. One thing you should not do is dump all production services on an SRE team, because that will not work. Getting started with SRE will work better if you start with SLOs, but if you just dump all the services that you have to your current SRE team and say, please make SLOs for all of these and please run them in production, you will find that will not scale and it will not go well. Typically in Google, SREs are a scarce resource by design. Not all the teams get SRE, and it depends on the importance of the product. So there are typical products that have millions of users that don't have any SREs at all. They have only developers taking care in a normal fashion as other developers in organizations. You should think of SREs as a force multiplier, so you bring them to add value to your product, and they should not be the gatekeeper. You don't want to give them the keys to the production, hand them there, and then they will start saying no, no, no to your developers for everything possible. It should be a shared agreement work, and it should, the teams still work on the same product and they still have the same goal. Now, an overall team doesn't have time to make tomorrow better than today, and you won't set them up for success if you just dump all the products to that new team. And it's about starting small. Do a good job of dealing with the most important pieces first, and you can start then growing, and adding more and more production systems over time. You will see probably that SRE teams will start having solutions that impact your entire organization. They will build some internal tooling that just starts being adopted by other developers because they're happy with it, and it solves some of their pain points. So again, that's an added benefit by having somebody focused on reliability. And if you do make the mistake of adding too much overload for your team, you should have a mechanism to back pressure to your dev partners. By sharing the responsibility of running the application in production with your entire dev or DevOps orgs. So the best part is, prior to taking a new product, is